So there's a few things we want to discuss before we dive into the higher order functions. The first thing we need to talk about are what are closures? You may be familiar with closures, but we need to really break it down. So closures are self-contained blocks of functionality that can be passed around and used in your code. Closures in Swift are similar to blocks in C and Objective-C, and to lambdas and other programming languages. But the takeaway here is they're self-contained blocks of functionality and they can be passed around. So this is very helpful. So it's like a little machine that can do something and you can pass it around and loan it to your friends. That's the great thing about closures is they're self-contained and they can be passed around. Now, closures capture and store references to any constants and variables from the context in which they're defined. So wherever a closure is defined, anything else in scope at that time is in scope within the closure. So even though you declare and assign a variable outside of the closure where it's defined, everything in that same scope is still in context for that closure for when it's executed. So it could be passed around, but it still has access to all those things when it's executed. This is known as closing over those constants and variables. Swift handles all the memory management of the capturing for you, so that's handled. You don't have to worry about it. So let's look at a quick little example of how we might use closures and the purpose. So let's say you have a function. This is just a regular old function, takes a string and an any, and it returns a string. And we won't worry about the implementation. It just returns this encrypted string constant. So here's your function, pretty basic, no big deal. But then let's say you want to have that function in something. You don't want it just lying around. So you put it in a class called encryptor, and you have that very same function in that class. Then in another part of your code, you have this function called encrypt, and it takes a string and it takes an encryptor. And then it calls the encrypt function on that class instance and returns it. So it takes the encryptor that's passed in, and then it can call that function that it's really interested in and manipulate it from there. So pretty standard stuff here. But it sounds like the job for a protocol. So you might want to be able to pass in different types of encryptors at different times, depending on the encryption you're using. So you defined a protocol called encryptionator, and it defines the encrypt function. Your encryptor already implements that function, so it just has to claim that it implements encryptionator as a protocol. We're all fine there. And now your encrypt function can take the string and the encryptionator and call encrypt on it. So it sounds like we're doing a lot just to really get down to that function. That's what we really care about, this encrypt function. It doesn't matter if it's in this class or that class or anything else. We really just want that functionality to encrypt something. So wouldn't it be great if we could just pass in that function as a type instead of the class as a protocol? Well, that's exactly what we're talking about here. We just want the function. I want to be able to pass in a function to encrypt as the encryption function type, say, and then just call that. Well, that's where we are. That's where we're starting. And if it's a little bit confusing, that's fine. We want the fog to settle in, and then we'll clear it away. We sometimes have to break you down before we can build you back up. But this is where we're starting, and this is where the fun's going to begin. So now that we have a pretty good idea of what closures are, let's talk a little bit about functions. Well, we're still talking about closures because functions are named closures. That's right. So if you know what a function is, just take away the name and you pretty much have a closure, and vice versa. So let's look at some examples. So here we have a closure and a function. Notice that they both have two parameters, val1 and val2. They both have types for those parameters, ints. They both have a return type of an int, and they both return the sum of those two. Now the syntax is a little bit different, and again, functions are named closures, so this function has a name. But for the most part, they do the same thing. Take two ints, add them together, return the sum. The difference is this closure is a little bit easier to pass around as it's defined here, whereas this function over here, you don't typically pass that around to anything. And we'll see other ways of doing this, but we just kind of want to see the similarities and differences for now. So again, what are functions? We talked about closures, but what are functions? Well, global and nested functions, as introduced in functions from this documentation, are actually special cases of closures. Closures take one of three forms. Global functions, this is what we're used to. These are closures that have a name and do not capture any values, so nothing within the scope at that time. Nested functions are closures that have a name and are captured values from their enclosing functions. So these are functions that are defined within other functions, not too common in my experience. Closure expressions are unnamed closures written in a lightweight syntax that can capture values from their surrounding context. That's what we talked about in the previous video. So again, global functions are closures that have a name. Nested functions, we don't deal with too much, and then there's regular closures. So again, functions are just named closures. They don't capture their scope. But other than that, they're pretty much the same thing. So from that point on, we can treat them pretty similarly. And again, this is where we're going to start with these understandings of closures and functions. Once we start thinking of them in a little bit different terms, we start seeing the power of what we can do for them. And that's where we're going. So we've been talking about closures and functions and how functions are closures with names. Well, also, it's important to understand that closures and functions have types. In fact, they're first-class types in Swift. So they also can be types for parameters and functions. Well, what do you do with parameters and functions? You pass them in so they can be passed around. Again, going back to the definition of a closure, it can be passed around. So our examples before had a type. They took two ints and returned an int, and it looks just like this. Int returns int. At least that's how I say it. What do I know? I used to say ASCII was ASC2. I thought it was Roman numerals. I read everything, so that's usually how I pronounce it. So I would say the type of those closures were int return int. So this function has a type. It takes two parameters, a string and an int returns a string. So I would say that type is string int returns string. That's its type. And just like these parameters have a type, a string and an int, this function has a type. So we could assign it to something of that type as well. So here we have a variable called afunc. And after the colon, we declare its type. String int returns string. Well, do we have anything that's of that type, string int returns string? We do. The function stringify. So we assign stringify to the variable afunc. Since it's a variable, it could be assigned to other things that have that same type, string int returns string. Further, we can call that function. We can say print afunc and takes two parameters, test and a 5, the string and the int. Well, that would print test 5 because that's what stringify does, and that's what afunc is assigned to. So I know this might be confusing, hopefully not. Hopefully you can think about it for a few seconds and you'll understand that functions have types. So constants and variables can have types. They can be assigned to things of that type. And in this case, our afunc has a type of string int returns string, which is what stringify is, so it can be assigned that. Well, what do you do with a function? You call it. So we can call stringify or we can call afunc because it's just assigned to stringify. It's the same thing. So we can assign these constants and variables to functions and closures, which means we can pass them around too. This is where it starts to get really exciting. As I mentioned in the last video, since closures and functions have a type, you can make a parameter that type and pass the closure or function in. So just like a type for a var or a let, you can use a type in your parameter list for a function, and then you pass a closure or function of that type in. So let's look at an example. We had our stringify function that takes a string, an int, and returns a string. So its type is string int returns string. Well, now we have this function called uses string factory, and it takes a parameter called string funct. Well, what's the type of that parameter? It's string int returns string. So it needs to be passed in something of that type, string int returns string. Do we know something of that type? We sure do, stringify. So we could pass in stringify as this parameter. And then this function uses string factory, could call it and return its output. In this case, it's calling it with number and 11. Stringify concatenates those two, passes it back. But we could pass in anything of that type. So let's say we have a constant called afunc. Its type is string int returns string, and we assign it to stringify. Well, now we could pass in afunc. We could call use a string factory and pass in stringify, or we could pass in afunc. It's the same thing again. So now, not only are we assigning functions, i.e. named closures, to constants, but we're also passing functions into other functions as a parameter. Starts to get a little crazy, right? Is your head spinning? That's not a bad thing. That means we're learning, we're growing. So let's keep moving along with this. We're going to take these concepts and build on them continually. It's going to be so much fun. So you're doing great, so let's keep going. So as we've been talking about types for closures and functions, sometimes they can get a little verbose, right? So we've had some pretty simple functions so far. So their types have been string int returns string or int returns int. That's fine. But when you have 3, 4 types that are being passed in and their names are a little bit longer, or if you have a bunch of different of the same type, like int returns string, that's not very descriptive, is it? We're not really sure what each of those strings are or what's being done. This is where type aliases can come in for these types for closures and functions. They specify the type without being so verbose, and you can use those in the parameter list and in the type declarations instead of the long int string returns int. So let's look at an example. So now we have a type alias called combines two strings, and it defines the type string int return string. So whereas before our uses string factory function took a string int return string, now it can take as a parameter combines two strings. And our afunc constant can be of type combines to strings and be assigned the stringify function. You'll see this sometimes in frameworks where the type is defined in a type alias so that you can get a better sense of what's going on. You can still go to the definition or use autocomplete to find out exactly what needs to be passed in or what the type is, but the naming of it is a little bit cleaner and it's more communicative to other developers. So this is just something you'll see from time to time in different frameworks that you should be aware of, that they're using type aliases in many cases. Just go to the definition of it, use the command, click on it, and then jump to it in the code. You'll be able to see where it is. So let's keep moving along and learn more about how we can use closures and get into those higher order functions.